All right, let's take a look at our last simple machine, the screw. First, I want to make the connection that a screw is actually an inclined plane. If you imagine taking an inclined plane and wrapping it around a cylinder, okay, then that's how you get your threads. Your threads are a continuous ramp that is just wrapped around in a circle. Okay, so really a screw at the core is an inclined plane if you really want to break it down. For the sake of calculating mechanical advantage, we'll start with ideal mechanical advantage though. In the context of a screw, we want to understand where is the effort distance, where's that distance traveled by the effort force, and where is the distance that's traveled based on the resistance. Okay, well, a screw, what happens as it rotates, right, this is going to rotate, it can be spinning somehow, whether it's through a screwdriver or a wrench, or even if you just grabbed the head of the screw bolt with your fingers and tried to twist it, you are going to be twisting this, right? But the result of that is that the screw, okay, should move in this direction. Let's change colors. Okay. So it's going to follow the axis. As you twist the screw, it's going to move in or out. And so the distance traveled here, okay, is due to the resistance. Now, the distance of the effort really depends on where you're applying that effort. If you, let's say, had a wrench, okay, it's the circumference of that path if you had the handle. So imagine putting like a socket on, and that socket has a handle. That's terrible drawing, but okay, so you've got a wrench here, and this is a socket, let's say, and it's gripping around it, and you grab right here. Okay, well, when you operate that wrench, your hand goes in a circle, and so that is actually going to be the circumference from the handle. Okay, remember circumference is pi times diameter, or a diameter is twice the radius. Okay, so if you know the length of the handle, that's really a radius. You'll want to double that to get the diameter, and then you have circumference. Okay, well, the distance of the resistance, we have to make sure we're comparing apples to apples. If we use the circumference, that's 1 revolution. We need to know how far will the screw move linearly with 1 turn. Okay, in 1 turn, the screw is going to move from one thread to the next. And that is called, this distance, the pitch. Okay, so the distance that correlates to 1 circumference, 1 revolution, is the pitch of the screw. How do you find the pitch of the screw? Well, that distance there is usually not given explicitly. However, when they are describing the threads on a screw, they may tell you TPI, or threads per inch. Okay, so if they tell us, for example, that we have 20 threads per inch, that means within 1 inch we would have 20 of these spaces, basically 20 threads. And so each one is going to be 1/20th of an inch. Right? If there's 20 of them making up 1 inch, divide that 1 inch equally amongst the 20, and each little one is 1/20th. So how do we get pitch? We actually just divide 1 by the TPI. Okay, that's assuming that we're working with this unit TPI, but we'll do that and keep it simple. So as long as we're working with threads per inch, and we know that number 1 divided by threads per inch will give us the pitch. That is the distance, the linear distance here from one thread to the next, and that is how far the screw is going to move linearly with 1 turn. So we're going to rewrite this formula here as 1 over TPI. 1 over TPI. Okay, so at the core, It's really dE over dr generically, but in the context of operating the screw, we've got a handle somewhere, so we need to know the circumference of that path, which is going to mean you need to know the radius of the diameter. So pi d or 2 pi r will help you get the circumference here of that circle. And then we need to know how far the screw will move this direction, and that is the pitch of the screw, which is found by 1 divided by the threads per inch. And that's how you get IMA. AMA is simple. You're just going to have to know the actual forces. How much force did it take to push on that handle? How much force is yep, I got that right. How much resistance force is there in the screw? You know, as it's trying to move linearly, it doesn't want to move, so how much resistance force is there, and how much effort does it take to push on that handle? And so AMA is the same.